Suppose we have a regression that we're interested in estimating, regression, and our regression has as outcome variable the money that a person used to buy GameStop shares in the stock market, on Robinhood or on whatever stock exchange they use, last week, the week of the 25th of January 2021. And we're interested in how income, person's income, affects how much money they use to buy GameStop. And our sample might be a large sample of individuals. And we want to know, well, did poor people invest a lot in GameStop, or was it really people with higher income who invested in GameStop? So that's why we have the sample. And we go ahead and collect our large sample, and we run our estimated regression, and let's say this is what we get, that the money invested equals 2,000 minus 6.2 times the level of income, where we're measuring the level of income in thousands of dollars. So 20 means your income is $20,000, 50 means your income is $50,000, and 100 means your income is $100,000. We have a standard error of the coefficient, right? This is the standard error of beta 1 hat, the standard error of the coefficient, 2.4. So our t-stat is 6.2 over 2.4, which is bigger than 2 but less than 3. So our coefficient is certainly statistically significant in that sense, right? And so we have this coefficient, and enable this of 6.2. It enables us to see that it appears that people with higher income invested less, because we have a minus sign, right? So if you're the expected value of how much you invested in GameStop, if you had an income of 20, is 2,000 minus 20 times 6.2, which is roughly 120. So this is approximately 1,880. If your income were 100, then the expected value of how much you invested in GameStop, how much money you invested in GameStop, is 2,000 minus 620, which is 1,380. So richer people invested less in GameStop, and that's, we have our conclusion, right? Unless we think about this problem and think that, well, gee, it seems like maybe there's an omitted variable, because we know from all the press reports and our own friends and family that maybe it was young people who invested in GameStop. And young people are usually poorer than older people. So we need to add the variable age to the regression. So our regression model should have been this, that the money invested in GameStop depends on income and depends on age. Now we estimate that with our sample. Suppose we get the following regression results. So how much you invest in GameStop, constant is 2,800 plus 5y minus 40 times age. And notice now what we have is the expected value of how much you invest in GameStop if your income is 20 and your age is 20 is 2,100. So that's your predicted level, right, of investment in GameStop. And our expected, if our expected age were 50, we would be expected to invest a lot less in GameStop. And now we can see that the coefficient on age is quite large, so that if your income went all the way up to $100 and your age were 50, you're still investing a lot less than a young person whose income is only $20,000 when we make that comparison. So indeed, omitting the variable age biased the estimate of the effect of income on purchases of GameStop. So the omitted variable bias was that our coefficient on income looked like it was negative, that richer people invested less, but that was actually biased because we had omitted the variable age. Once we included the variable age, we saw that people with higher income indeed invested more. So the coefficient on income was indeed positive. higher income people invested more than poor people, than lower income people.